Okay, so today we're going to solve systems of equations using our inverse matrices that we found yesterday. Okay, to find an inverse matrix, we first found the determinant, correct? And the determinant had to be what? Not zero, right? It had to be not zero, and then I could keep going. So you will be finding the determinant, and then you will be using that. I've told you before, we don't divide matrices. We don't. We multiply by inverses, just like we don't divide fractions. We multiply by what, Elena? Reciprocals. Okay, so there's things we can't do with matrices. There are some matrices we can't even multiply by their inverse because they don't have an inverse, correct? So the steps that we are going to be using today are as follows. The first thing you're going to do is write the system as a matrix equation. So here's our system, 2x minus y equals 2, 2y equals 8. That is a system of equations, correct? And we have done graphing, elimination, substitution, Gauss-Jordan elimination, right? To solve systems, this is another method to solve a system of equations, okay? We are only going to be doing 2 by 2 because we're all going to do it by hand. If I decide I might show you how to do a 3 by 3 and use the calculator to do it. But yeah, I'm taking your calculator. So it might be something next year we get to when we get to our matrix unit in pre-calc. So we can have some fun with it since we got so far this year. Okay, so what a matrix equation is right there. It's AX equals B. Well, let's see. What do you think's an X? What is X?
A variable.
A variable. So what do you think I put in my X matrix?
Any
Variables. What variables do I have?
2.
No, what variables?
X and Y.
I have X and Y. Okay? What do you think's in B? Because it says equals B.
The numbers.
What are those numbers?
2, 1.
2 and 8.
If they're
Numeral.
Equals B. What are these things?
2 and 8.
2 and 8. What are they to the equation?
The
Answer.
The answers, the solutions. Yeah? You guys are like,
I just said 2 and 8.
okay, so 2 and 8. The solutions. Yeah, not so hard. Still haven't told you what's an A. But what do you think's an A? There's nothing left but what?
The 2s and the 1.
What are those numbers called? We've made this
What
kind of
is-
matrix before when we did Gauss-Jordan elimination. What is 2 to x? What's its relationship? What is negative 1 to y? What is 2 to y? The what? It's the number in front of the variable called
Coefficient.
the coefficient.
Wow.
Good job.
Haven't we made coefficient matrices before?
Sure.
Probably.
When we did Gauss-Jordan elimination? Did we not?
I can't remember.
Sure.
Okay, what do we put here?
The
0, because there is no x, right? So this is A, X, and B. This X normally has a little flag to show that it's a matrix, that it's a capital. We don't normally name, yesterday you guys tried to name a matrix X and I wouldn't let you, because when we name a matrix X, it usually means it's a variable matrix. It has variables in it. So we don't name it X. Okay?
Okay.
So that's the first thing we're going to do. Then we're going to find the inverse of the coefficient matrix, which we did yesterday, right?
Yeah.
In order to do that, we have to find the determinant, and then you take 1 over the determinant, swap A and D, and negative B and C, right?
Yeah.
Okay,
So
and then we're going to use the inverse of the coefficient matrix to find the left-hand product. What does that mean?
The
On the
answer
left.
It's on the left, because matrix multiplication is not commutative, is it?
No.
No. So if it's on the left-hand side, it has to stay on the what? On the right-hand side.
Left.
The left. Do you
Left.
notice? Do you see that?
Yes.
Is that important?
Yes.
Okay. I've proven to you that matrix multiplication is not commutative, and you will not get. Sometimes you may get the right answer, but you will not get the right answer in general. So when I multiply the inverse matrix times matrix A, I get the identity matrix. I showed you that yesterday too, right? What is the identity matrix of a 2 by 2?
One,
One,
zero,
zero, zero, one. Boom.
Okay, so 1001, and when I take 1001 times x and y, I still get what? X and Y. Okay, and then over here, I'm going to get the answer. I'm going to get a matrix xy, and I'm going to get an answer xy. So that's what we're going to do.
Okay.
Every single problem today.
Yay.
That is.
Is that
The
least
whole
amount
5 of them.
that we can?
Well, we're going to do it. I'm waiting for them to write.
Yeah.
And again, guys, I will get you. So I don't think 5. It's not that it's hard. It's just we need a little bit more repetition. I don't know if I'll either give you more or just put a few extra of them on the review. Probably would be fine too, right?
Yeah.
Okay. So, but in this, we are practicing scalar multiplication. We're practicing just multiplication of matrices. We're practicing finding an inverse. So we're pretty much practicing everything we've done in the whole chapter, haven't we? Okay. That's why I decided there's no reason to drag this out. Let's get some more time with probability and stuff and have some fun. Maybe we can do some fun things with that. And,
Yours like a funny around there.
okay, do you want to be crammed in stuff or do you want to have time to think?
I don't think.
Okay, yeah, we know. Everyone ready?
Yeah.
Okay, so this is the same matrix we just had. I just didn't, last hour I squished it all on that slide and it was horrible. It was not neat. Okay, so the first thing I need to do is make my what?
The coefficient.
I need to make my matrix equation. So coefficients.
Coefficient, variables, and then the solutions.
So coefficient would be 2, 0, negative 1, 2. Okay, that's my A.
X and Y.
And my X is going to be XY equals
2, 8.
2, 8. My solutions. So we need to find the inverse so we can go from here, right?
Yeah.
So in order to find the inverse, what do we have to find first?
Coefficient. No.
The determinant. So the determinant of A, and I'll write it out one time, is going to be 2 times 2 minus negative 1. So it's going to be what? Oh wait, not minus negative 1. How about 0 times negative 1?
Shouldn't it just be plus 1 if you want?
Well, it's going to be 0.
Well, yeah, it's gonna be 0, but like.
Yeah.
would've been plus.
Yeah, but it's going to be 0. So my determinant is what?
4.
4. So there is an inverse, yes?
Yes.
If it's 0, then what? 2 times 2 minus negative 1 times 0. It's right there. Okay, so A inverse is right here, right?
Yep.
So it's 1 over the what?
4,
1 over the determinant.
and equals
And then I switch the 2 and the 2, which is still what?
2.
2 and 2.
and 1.
And then negative and the negative. So 1 and 0. I always switch my diagonal and then do the negative of the other diagonal. I don't like write it in any kind of order that I usually do. So now I distribute this 1/4, yes?
Mm-hmm.
My suggestion to you is not to reduce. Does anybody know why I say maybe don't reduce?
Are you gonna make us check it?
We'll check it differently than we did yesterday, but we're not going to check those.
You have.
Okay. If, when I go and multiply by this, I have to add them, yes?
Yeah.
And if I reduce them and they don't all reduce the same, do I have to go backwards and get common denominators again? Yeah. Yesterday we found just the determinant, so you should reduce it, right? But yesterday, or today, sorry, we're using the determinant to find the solution, so is that my end result? No, so I don't have to. If they all reduce by 2, that's great. But if they don't all reduce down, then I would I would not, if they don't all reduce to whole numbers or they don't all reduce by the same, because the same denominator, I wouldn't do it because you're just gonna have to go back and get common denominators regardless. Yes,
Shouldn't it be a -1?
no, because of the formula says negative of those two. And it was a negative to begin with. He knew that because he thought it would be -1. Okay, so we had A x equal B, and we have to now take what? A inverse times
B.
B. Look, we got A inverse right there already to be put on the left, right?
Uh-huh.
So I put B,
2, 8.
2, 8. So I have A inverse and B, yes?
Yes.
So I have a 2 by 2 and a 2 by 1. So I'm going to get a
2 by
2 by 1. I'm going to get an X and a Y. Okay, so 2 times 2 times 2 fourths is
8.
Well, 4, 4.
it's 4 fourths,
So 1.
1. But I'm gonna leave it. Well, okay, we'll do 1. And then 1/4 of 8 is what?
1/4 of 8.
1/4 of 8 is
2.
Oh,
Not a secret. Okay, well 0, right? And 2/4 of 8 is 4. So 3 and 4. So what is X?
3.
3.
Y is 4.
And Y is 4. Because we know that in order for these two matrices to be equal, they have to be the same, right? So now we're going to plug it back into the original equation. So X is 3, Y is 4, right? So 2 times 3 is 6, minus 4 is
2.
2. And 2 times 4 is
8.
8. So did we do it right?
Yeah.
That looks pretty.
Okay. So there were a few steps, but could I do it nice and organized? If I had more paper, I would just go down with these. Like, I would not have gone that way, I would have gone this way. But I don't have more paper. That's a technical issue. Questions before we move on to another one? Okay, so 3x minus 5y equals 7. 2x plus y equals 4. So first thing I'm going to do is what? Matrix equation. Okay. So what's in the first matrix?
3.
What are those?
2.
What are those?
Coefficient.
Coefficients. So 3, 2.
-5, 1.
So that's my A, right?
Yep.
And what's in my X?
X, Y.
X, Y. It's whatever variables are there, correct?
Yes.
We all know that when we solve systems of equations, all the variables need to be lined up. Like it needs to go X in a column, Y in a column. They should be in alphabetical order, just those things like that. And the last one?
Is 7, 4.
7, 4, which are the solutions. So our goal is to have X equals A inverse times B. Yes? And A inverse has to be on which side of B? The left. Okay, so first step of finding the inverse,
More.
find the determinant.
Determinant.
Determinant of A,
Equals 3 times 1.
so 3 times 1 is
3.
3 minus
Minus a negative 5.
negative 5 times 2, so negative 10,
Yeah.
so plus 10. So I get
13.
13. So is there an inverse?
Yes.
Yeah.
So A inverse equals. Now please make sure you're labeling your work, guys. When I go and look at your work, I should know what your determinant is. I should know what your A inverse is. Do not just do random matrices and multiplication around your paper,
Come on now.
because I can't grade that. Okay, so it's 1 over the determinant,
13.
and I switch the 3 and the 1, and I take the negative of the 5 and the 2. And then I just distribute my scalar, don't I?
So it'd be 1/13.
So I have 1/13, 5/13,
-2/13.
inverse matrices are going to look like that unless you start off with fractions, right? If I start off with fractions, they'll probably be more whole numbers, right? But sometimes inverse matrices look not very pretty. Okay, so I now need to take A inverse times what?
B.
B.
7/4.
So I get 7/13
And not 20/13.
plus 20/13.
So, 27.
Okay, and then negative 14/13
Yeah.
plus
12/13.
12/13. Just doing my normal matrix multiplication, right? Row
Yep.
times column.
So 27/13,
That would be
So 27/13
and then -2/13.
and negative 2/13. So that equals what?
Equals
XY.
XY. So
Not 14.
where?
Negative 14/13.
You need to sit up front if you can't see that. Because that's not even messy.
Yeah, it is.
No.
No, I just didn't know if it was supposed to be 14 or it was supposed to be 4.
Oh. So I got 27/13 and negative 2/13. Imagine if you would have had to do that like with Gauss-Jordan elimination. You guys would have been panicking, right?
No.
It wasn't a very bad way to get fractions, was it?
No.
No, not really. And you'll have fractions and you'll have to reduce them, but these don't reduce, do they? No. Not too bad. Concerns?
No.
Okay, we got two more.
I actually
Okay.
kind of like these.
I'm gonna let you start this one. Put your head down when you hit the roadblock. Oh, this isn't it. We have three more. There's no roadblock here. The next one has one. Oh, that's not 123. That's going to be on the inverse. I was skipping a step.
No, it'll be plus because it's a negative.
Be a negative 63. Am I still staying behind you guys?
You're kind of underneath, but
Okay, so wait a second.
wait, no, you're not. That's right.
Okay, did you guys get 1-1?
Yeah.
Are we right? Yes,
Yeah.
Selena?
I'm confused on how you got the 6 plus 117 over 123 on there.
Because they already had common denominators, so I just wrote the numerator over one denominator rather than writing two fractions. Because I'm going to combine them anyway. Because it would be 6 over 123 plus 117 over 123, right? So I just already did the denominator. Am I efficiently lazy? Okay, are we right? So 10 minus 9, is it 1?
Yep.
Okay, 7 plus 6, is it 13?
Yep.
Yes. Were you disappointed when it came out to be 1 and 1? Yes, you're like, I did all that work too, 1 and 1. And then you go back and look at it and you're like, oh duh. Because it's the only thing it could possibly be, right? It happens a lot. You get in your procedure and you're just like, woo, let me go. And then you're like, oh, okay. Okay, so
It's
not,
actually pretty easy.
Wrong way.
okay.
Oh, God.
Now,
No.
Oh, no.
do this one on your own.
Pretty much.
No. Just because there's a fraction doesn't mean it's a roadblock.
Yes.
You already said there's
You said
gonna be a
you
roadblock.
hit the roadblock. I
Well,
think Evan
no,
hit it.
not with a fraction roadblock. With the actual procedure that I gave you. There's a
It's gonna be the determinant. Okay.
Are you crashed because we're done?
I can do that.
Killer Iron Man.
Kendra, what's wrong with it? What do you mean by that?
It equals 0.
It equals 0. The determinant equals 0. So does it have an inverse? No.
That's why.
So there's no inverse. So we have to find another way to solve. I get it. Let's do Gaussian elimination. You guys up for it?
Why do we have to solve it? There's no inverse.
There's no inverse. That doesn't mean there's not a solution.
There is no solution.
It means there's no inverse. So that means I can't use this method. So I can't use this method, but I could do Gaussian elimination.
I forgot how to do that.
I could do graphing.
No.
No.
Oh, God, no.
I could use substitution or elimination, right?
No.
Elimination is usually the easiest one to do, right? So we need to pick whether you want to eliminate 5 or X or Y.
Why?
Why? Okay, so I already have a positive and negative Y, so we're good there, right?
Uh-huh.
What would we multiply the numerator by to get just 5?
1,
Not 1/8,
No.
8.
Over.
8, just 8, right?
Yeah.
So I need to multiply everything by what? 8.
Eight.
Okay. So that gives me 1/4 of 8 is what? 2. Okay. And then 1/8 of 8 is what?
Yes.
1.
1. So negative 5 of Y. And half of 8 is
4.
4. Oh, that's taking a long time.
I was so gone. I was not thinking about what you were saying.
I was waiting. I was practicing my wait time skills. What do I get?
0.
Equals 0. What does 0 equals 0 mean?
Just 0 for 0.
No solution.
No.
Dang.
Why don't you just let it
What, sir?
happen?
Did you say something? No. How many times does 0 equal 0?
Once.
None.
Infinity.
All the time. Infinitely many.
We haven't
Oh.
done that in so long, I forgot that was a thing.
Same.
I say you just let it be no solution. It just seems so much easier.
At least I'm not going to make you have to go back and write the equations like we did with Gauss Jordan.
What?
Okay, what we had to do, we had to make x equal a, and we have to substitute it in, and I'm not going to make you do that. Okay, so there's just, you didn't do it.
Oh, here, makes sense.
Okay, so when the determinant is 0, can I use this procedure?
No.
No, it doesn't work for me. I have to
Yes,
find
you
another
can.
way.
Or we could just
No, you've got to do it.
No.
Okay, it's another one. This is our last one.
Ugh.
Nope.
There's one for our
There's only one. The last one had 3.
Many.
One is too many.
One too many, guys.
And guys, what's 2/3 of 4?
I don't know.
What's 4 divided by 2?
Two.
I don't
2, and 2 times 3 is?
6.
Oh.
Wait, so can you,
No.
You reduce and multiply.
so you can't do that?
Yeah.
A lot of help.
The other one didn't work because they didn't reduce.
I don't know about you all, but I like making that X.
Oh, shit, y'all.
You like making what?
I like making that weird X.
Oh, the.
Yeah.
And that's actually how in math you know it's a capital because it has the flag on it. You guys got the answer yet?
No.
Yep, 0.
It's just 1 and 1.
It's infinitely many. Nope, it's infinitely many. See that?
Evan
No
is
solution.
guessing infinitely many.
See that?
Good
No
job,
solution.
Evan. He's right though. Or I don't know. Fully right.
I think
Okay, did everyone get to 0?
Yep.
Hang on, wait.
Okay, so you tried another way now?
I have a question. How did you get 6 on the second part?
Because I took 4 divided by 2 is 2, and 2 times, because you have,
With multiplication.
Yeah.
Yep.
because 4, 2. Oh, okay.
So now we have to do the silly
Okay.
stuff again?
Now you have to do, are we doing elimination again?
Yes.
Yeah.
Okay, are we eliminating x or y? Please say x.
X.
Why?
X, because
There's a fraction, we don't want a fraction, do we?
and you multiply the bottom one by
You
2.
want us to have
Okay.
one,
So if we multiply the bottom by 2, gives me rid of the 2, it gives me a 3, but I need a negative 3, don't I? Don't I need a negative 3 to eliminate the x?
No.
Yeah.
Yeah.
So negative 2.
So everything by
Negative.
negative 2. So I get 3x
No solution.
plus 4y equals
Wouldn't it
8.
be minus 4y?
No, I'm on the top. Negative 3x minus 4y minus 10. 0 equals negative 2. So that is no solution.
Oh, it's definitely.
So in other words, if the determinant is 0, what are my 2 choices? Infinitely many or no solution, but you have to find another way to figure that out, right?
They're putting some of those on the test.
Of course.
Nope, she's not, Taylor. She just taught us it for no reason.
Evan.
Part of it.
What is
No.
Yes. Yesterday was just finding the inverse, and we did that.
Is there going to be anything like that on the?
Yes. Yes.